All right, thank you very much, Mark. I appreciate it. And I'm going to start moving through the slides. And everyone let me know, or someone let me know if you can see that the slides are being presented. Um, Alan Okamoto, can you see the slides moving?
Yes, I can, Dave.
Okay, good. Well, just an overview of the presentation. We're going to cover a number of topics. The purpose and benefits of M&B, understanding savings and guarantees, and some of the fine points of that. What constitutes a good M&B plan? Of course, you already have an M&B plan that you developed in conjunction with NORESCO for this project. Defining baselines, we'll be talking about what goes into that, and once again, that's something that's already occurred in this project, but you'll get a little more detailed understanding about what's involved in that. And then probably one of the most crucial things is understanding savings uncertainty. You know, what are the factors that can affect savings over time, and how you manage that uncertainty and what some strategies are. And we'll talk about different types of baselining. In this project, you're primarily using what's called an Option A M&B method, which has a equipment-specific type of baseline. But we'll be talking about that, and we'll be talking about some other types of baselines that get used in some types of projects. And then we'll actually talk about a few of the ECMs and as examples of M&B for your specific project. And we'll touch on the whole issue of stipulated savings, where you have to use estimation for parameters and what's involved in that, when it's appropriate to use it, when it's maybe not as appropriate, and understanding the differences between M&B options and the factors that go into why people select one option versus a different option. We'll talk a little bit about some technical savings examples, and then we'll talk just conceptually about what does it take to create high performance and high savings achievement over time, and what sort of data is used to monitor savings and track it. And then we'll talk a little bit about the whole concept of a performance contract, where an ESCO like NORESCO works with a Board of Water Supply in a performance partnership, where their mutual goal is to maximize savings over time and achieve the benefits of the project. So that's just a quick sort of overview. We go to the next slide. You can see that the basic definition of M&B is really a procedure that talks about what sort of data is going to be collected in order to evaluate performance of the building energy consuming equipment, and what's the step-by-step method that's going to be used as defined in the M&B plan to execute that process of measuring and verifying savings. Now, there's a variety of purposes for M&B. One of the ones that's the most obvious is this first bullet, which is you want to reduce future utility consumption and costs. So one way to think of it is, how do I avoid these future costs that I would otherwise incur if I didn't do this project? But also, by virtue of the fact that you're putting in new equipment, you also want to reduce future operation and maintenance costs, and hopefully you'll have fewer breakdowns, fewer maintenance issues because you're putting in new equipment. Another thing that is done with M&B is you want to evaluate your guarantee performance from a contractual point of view. Did NORESCO make their guarantee? How do we tell if they made their guarantee, and how is that defined in the contract? And then sometimes the data that's collected in the process of doing M&B allows you to increase future savings or find other opportunities or ways that you can enhance performance going forward. You know, it depends on the particular energy conservation measure how much of a value that is, but it can be a significant value, especially as it relates to control systems. As a good example of where opportunities often come up to improve savings over time. And lastly, just improving the operational control of the facility so that you have better, more tight control of operating parameters, and maybe better visibility depending upon your control system of what's occurring out in the field in real time with your equipment and major process loads in your case. Now, there are a number of ways that M&B data gets used. Obviously, there's the one we touched on in the previous slide, determining and comparing utility savings. But It's also to look at the predicted savings data, and then during the audit of savings against predictions, you see what that data is and how it's calculated. Also, you can guarantee, you want to see as determined by the contract whether the guarantee savings as defined in the contract and as evaluated by the M&V plan are proved out. And lastly, you want to quantify the actual savings based on savings adjustments. And we'll talk a little bit more about that later on. Because actually, what is in your guaranteed savings, the ESCO might actually achieve their guaranteed savings per the M&V plan and per the contract, but actual savings could vary a little bit because of the fact of savings adjustments or actions taken by the owner that reduce savings but are not really a liability of the ESCO. So what are some of the types of savings that you're looking at? Well, in Hawaii, it's primarily reducing electricity, primarily kilowatt hours on demand, kW. But on occasion, if there's backup power or emergency power facilities, there may be a small amount of natural gas or diesel fuel. And then there's also savings on materials, equipment or replacement parts, or reduced cost of future maintenance contracts, depending upon how your maintenance function is funded and budgeted. And lastly, there can even be reduction in water consumption, especially for cooling equipment, etc. Now, there's two perspectives on M&V. I'll call it a sort of a short-term and a long-term perspective. And the most important M&V data in some ways that's collected is during the investment grade audit period and during the construction period, where a lot of the measurements are being taken, or some of them immediately post-construction, some during construction. The reason why is because the accuracy of these measurements has a pretty strong effect on the ability to evaluate savings in the future, because if you don't establish a correct baseline or standard of comparison, you won't be able to effectively measure the changes in key variables over time that are actually what defines the savings that and the utility costs that you're going to avoid. So during the initial M&V effort, which I'm sure NORESCO already conducted during the audit phase, they went around and did data collection. They used energy saving modeling to figure out what the savings would be. They may have used spreadsheets, they may have used a little eQuest modeling, and they probably reviewed all your utility costs and consumption profile. I don't know, I'll just ask Aaron, was there anything else that you guys did, or does that pretty much cover your initial M&V efforts?
Yeah, that sounds pretty comprehensive. That pretty much covers it. Okay.
Now, you'll make a shift, as Mark noted at the outset, once you actually have construction done, which I guess is probably like in the order of 18 months in the future for you guys or something like that. You'll be shifting from meeting the guarantee, which you'll determine after the first full year of performance, to optimizing savings performance over time. And this is where trend log data and O&M strategies become very important for exceeding the savings guarantee. Because there may be opportunities, as I said earlier, to really fine-tune your control strategy or address an issue that you find with some equipment and resolve it, and therefore actually improve your savings performance over time. So what's the primary benefit of good M&V? Well, this graph is just a real simple sort of comparison, green light, red light, which is if you do good M&V, your savings persist. And typically, the percent of savings that you realize relative to your projected savings could be anywhere from 100 to 120%. If you don't have good M&V and savings drift, especially controls over time, you may find your savings eroded as the years go by if you don't keep tuned with your controls especially. So what are the benefits of M&V for the people who are managing the agency? Well, for one, it gives the agency greater confidence in the project's benefits, which leads to future projects. We've seen this significantly at airports. They're now sort of on an official phase 2, but it's really almost like a phase 3. And actually, if you counted transportation as a whole, there's a 4 and a 5 when you count harbors and highways. So that information is used to support future decisions. If you're trying to estimate emissions reductions, if you're trying to claim a credit for that, which you may be, then having good M&V data on avoided utility consumption allows you to estimate those reductions. As we talked about earlier in the previous slide, you want to maximize the persistence of avoided utility costs over time. And so tracking allows you to do that. And M&V may provide, if it's necessary, the data required for a baseline adjustment. There may be some trend log data that tells you something's going on that's going to require you to make a baseline adjustment of some kind. And it even can help you in managing future utility and capital budgets. You may identify new projects based on what's happening, and it may help you figure out, well, here's the savings that I might be able, based on the M&V plan that I'm running now, I may be able to estimate the savings from a future capital budget. But there's always multiple audiences for M&V. One is that the engineering staff wants to see technically the definition of savings and that the performance on savings is there. But there's also a budget officer typically who's looking at the contract, wanting to make sure that the financial aspects of the savings guarantee, that the data is there to support the cost avoidance as well from the savings guarantee. And there is sort of the executive summary stuff that goes to agency executives or the legislature who wants to know about what the benefits were that were created by the project. And it provides data required to claim utility incentives if those are available and participate in other utility programs, which in this case, I think one of them that's important is net energy metering for the PV systems, for example. One thing I'd say is that there's benefits of M&V for operations as well. You can reduce operation and maintenance costs by having better operating and better controlled equipment. You may have better ability to remote monitor equipment performance, which may save you legwork in the field, and there can be some labor savings for operators who don't necessarily have to go remotely into a field to determine the condition of equipment. And it can improve overall reliability and control of equipment as well. So other benefits for operators that can come from M&V is you can avoid or reduce future equipment repairs, maybe improve indoor environmental quality for buildings like the one on Britannia Street, reduce occupant complaints, and provide performance feedback and accountability for the ESCO and the building staff on the project. And one of the goals is really continuous improvement in project performance over time. And that's what the partnership between the ESCO and Florida Water Supply is about. Why is it important? Because if you don't have that continuous focus on improving performance, then equipment can degrade, controls can drift, etc. So this little iceberg here is sort of the heart of the ESCO model in a way, because we all know that if you want to go out and spec and bid a project, you can do that. But if you're focused only on first costs, you might be missing the bigger picture. What about equipment failures in the future, or performance problems in the future, or energy costs in the future? In other words, if you look at the life cycle cost, there's lots of other things to consider besides the first cost of equipment. And if you don't take those hidden costs into account and all the operation and maintenance costs associated with the equipment as well as energy, you might not make the best investment decision. Equipment price is usually only 5% of life cycle cost. So the point is, don't focus too much on the 5% and forget about the 95%. Because it's not a good strategy for minimizing the life cycle cost of your facility and equipment. Now, going a little deeper into the engineering perspective on M&V, this is a very simple way to think of it, but conceptually useful, and that is that you're measuring variables to quantify changes pre and post the ECM installation. And what you're partly doing is, in addition to those measurements, you're essentially verifying the technical potential to generate savings in the future by showing, hey, the efficiency parameter has actually changed. Or if in the case of you measuring a time-related factor, the operating hours have actually changed, for example. And usually when you look at energy savings, you're going to be comparing a baseline minus the measured and or calculated changes, plus or minus any adjustments that might have occurred to affect the baseline. And this sounds all conceptually very simple, but it actually, especially when you have very large variable loads with interactive effects, that can require more complex calculations. So this is a sort of an innocent slide, understanding savings, but it hides a little bit of complexity and sometimes confusion that arises when people are looking at this, and that is that suppose there's 100 units of savings that are predicted in that first bullet. Well, that 100 units of predicted savings is probably accurate to plus or minus 5 or 10% based on the engineering analysis conducted by the ESCO and their pre-construction measurements of various parameters. And typically the ESCO is going to hedge their risk on achieving the predicted savings by only guaranteeing 90 to 95% of the savings, and that's what they'll put in the contract. And so if they think their engineering audit and analysis shows we can probably predict there'll be 100 units of savings, we're only going to guarantee though 95 to maybe 90 units of savings, and that's pretty typical. It provides them a performance safety margin. Then the verified savings are the savings that are established by actually executing the M&V plan, and it's quite common for the M&V plan, once executed, to show that you've actually exceeded the guaranteed savings by 5 to 10%, and it's not unusual to even exceed the projected savings. So it's quite possible for the verified savings to come out. If the predicted savings were 100 units, you could come out at 105 potentially with the verified savings. Now the last one, and remember all three of those bullets use the word savings, but they use them in a slightly different way. There's predicted savings, there's guaranteed savings, and the verified savings, and those are potentially three different numbers, although they're related to each other. But then there's a fourth one, and that's actual savings. And actual savings may be less than or greater than the verified savings due to a variety of factors. Example given is owner's actions. For example, the owner could do something that had nothing to do with the ESCO that would actually increase savings, but if it didn't have any relationship to the ESCO project or the ESCO equipment, then the ESCO wouldn't be allowed to count that towards their savings guarantee. I mean, it would be great for Board of Water Supply to have those savings, but it wouldn't be factored in when calculating necessarily the verified savings if it was something that was completely an owner initiative and not something that the ESCO was involved in any way. It's not that common, but it could happen. There's also the case, and this is probably the more frequent case, where actual savings are a little less than the verified savings, and that's because the owner has taken action to increase consumption, and it's outside the responsibility of the ESCO, but it's something that the owner needed to do for other operational reasons, and it increased consumption. So even though the ESCO made their guarantee, they did everything according to what the plan required, and all the measurements were what they were required to be to verify savings from the ESCO project. Actual consumption could still be a little bit higher than anticipated. You might not avoid all the utility costs, not because of anything the ESCO did, but because of some action taken by the owner. And really important thing is to understand that savings performance is really a shared responsibility. There's no way that you can turn it over 100% to the ESCO. A percentage of the risk is pushed off onto the ESCO, but some amount of responsibility always remains with the owner in the proper operation and maintenance of the equipment. And so that's just a given. So there's two ways to think about M&V. There's sort of a guarantee scorekeeping when you look at it at the contract and you you answer a simple question. Did the ESCO make their guarantee this year, or did they not make their guarantee this year? That's a yes or no question. But there's another perspective, and that is, what about over the long term? Is there some opportunity here to increase savings over time? And can we optimize saving performance? It's great they met their guarantee, but now I wonder if there's anything they can do, any action they can take that'll actually bump performance up a little higher. A great example of this is large variable loads like chillers. They provide a lot of opportunity to optimize savings by tweaking and tuning the controls, playing around with chiller staging and things like that, and optimizing the kW per ton. So that's just an example of opportunity sometimes for optimization. Even lighting controls can lend themselves to this. If there's something other than simply on-off occupancy controls, if they're dimming controls, for example, you can do some tuning with that and often get some opportunities to pick up some additional savings. So the contractual need, once you shift out of the engineering focus, what you need there is a definition in the contract that defines sort of the level of accuracy that is required, and also the safety margin that we talked about earlier. What's an acceptable range of performance uncertainty? Because in engineering, there is no such thing as accurate to 100 decibel places or something like that. No engineer works on any project, with very few exceptions. Maybe in rockets or something like that, where that's the level of accuracy. So there's always some degree of performance uncertainty, and what you want is a reasonable safety margin that manages the performance uncertainty associated with your equipment performance. And then you want to allocate the savings risk between the ESCO and the agency appropriately as to who can best manage that risk and who can cost effectively manage that risk. And that's typically what's done in an M&B plan. And then you have to have a well-defined guarantee evaluation process and procedures, which is what the M&B plan and the contract do. All of this has to be well-defined and well-specified, because otherwise, when you go to figure out, did you comply with the contractual definition of guaranteed savings, if your process isn't well-defined, you'll go through and you won't come up with a clear, unambiguous answer. So another question that's always asked, and this is really at the heart of M&B, is how much certainty do you need, and what's the cost of reducing uncertainty? Well, there's sort of a break-even point. The cost of M&B, you can always spend more money on M&B and collect more data, but at some point the value of improved certainty, as you can see where that little dotted line is less than the cost of improved M&B, and that's sort of an idealization. You don't really know exactly what that point is. It's more like parallel lines. There's a boundary there, but ultimately what you want to do is have a good M&B plan where you spend enough money to improve your certainty, but you don't want to spend more than you need, where the value of improved certainty is now less than the cost of the money you're spending on M&B, because then you'll be in a non-economic position. So the key is, you don't want to find out that you spent $1 on M&B to find out you didn't save 10 cents. That's a bad investment. And so cost effectiveness is really a driver on that. Okay, if we go look at the next one and say, well, what are the factors that affect the cost at an appropriate level of M&B? Well, first off is how much money is at stake. That's an obvious one. If you're doing some little envelope project where you're sealing up some air leaks and you're saving $100 a year, maybe you need an engineering model or a very simple spreadsheet calculation, but you really can't afford to put little flow meters on that air crack. That's not going to be useful. The complexity of the ECM, how variable is the load on it, and what other factors affect the performance of the ECM? Is it sensitive to weather, or is it not sensitive to weather? Then you look at whether or not there are other ECMs interacting with each other. Well, the more discrete ECMs you have, potentially the more of them could interact with each other if they're in the same functional facility or building. And then you look at how uncertain the savings are, as we talked about in that previous slide. Are the savings highly certain? Lighting savings, appropriate measurements of the baseline and appropriate design, lighting savings have relatively low uncertainty. If you've done a good job of defining operating hours and you've measured pre and post KW and accounted for diversity and things like that, that's not too complicated. That's much less true of a central chiller plant, which might have a very diverse operating set of parameters and may require a more complex strategy and a bigger investment of M&B. It also depends on what's the risk allocation for achieving savings, if savings aren't achieved. And then sometimes there are opportunities from the M&B data to produce other value, to improve your operations or avoid operational costs, not necessarily utility consumption, but reduce your future operation and maintenance costs. Well, that's a value you want to account for, and that may make it worth spending a little bit more money on M&B. And then the question is, do you have an energy management control system available for the equipment that you're interested in? If you do, you may have an opportunity to use it to improve the performance of that equipment. So that's just a variety of factors. Then we get to the actual plan itself, and you say, what's the recipe for a good M&B plan? Well, they're typically negotiated. I'd say this first bullet is really crucial, and that's where the customer needs to be educated by the ESCO and in conjunction with the ESCO, where they come to a meeting of the minds and decide, this is the amount of money that's worth spending to reduce uncertainty, this is the right trade-off point between cost and accuracy of savings measurement, and we have an agreement. And then all the things we touched on earlier. When you do a good M&B plan, you get a good baseline that's well-defined. Your M&B plan can be effectively implemented in a cost-effective manner. You realize you know the data you're going to collect, when you're going to collect it, how you're going to collect it, with what instrumentation. You understand, the client understands how the guarantee process works, how it's related to the M&B process and the M&B report, and understands functionally how it works in terms of the contract. And then there's also, it's important for the operation and maintenance personnel in the agency staff understand and buy into the M&B process to the extent they're going to be witnessing measurements and participating in the process. And if it requires data to be collected from them that is necessary in order to help adjust the baseline, that's something they may be participating in. And just to also help them be trained so that there's proper operation of the project equipment, so it doesn't do something that would potentially reduce savings unnecessarily. So the M&B plan covers a lot of ground, but also it's sort of closely related to these other topics here at the bottom in the bullet. M&B is dependent to some extent on or is facilitated by having good training of Board of Water Supply staff and good maintenance provided by Board of Water Supply staff, and sort of a team approach to diagnostics of equipment performance with Board of Water Supply and ESCO, so that you can keep improving performance over time. So these are some features of what's a good M&B plan. We touched on it already, but the first bullet, a good balance between savings accuracy and measurement cost. Generally complete and relatively conservative calculations that capture all the significant project effects on utility consumption. A consistent method and process that allows the third party to come in and look at it and say, if I followed the same method and followed the same process and collected this data, I would come up with very similar results. That's important because if a third party comes in someday to review the results of your M&B report or your M&B plan, you want them to be able to understand it, and that means the data has to be clearly specified and defined. If they have to ask you 100 questions to figure out what's going on, then your plan is underspecified. So, in terms of the M&B plan outline, these are some of the things that would typically be in the M&B plan. What data is there? How are you going to collect it? What will be measured? what will be calculated or what will be simulated or estimated and who's doing it, and which variables are the most heavy variables. If you did an analysis of variance, what are the few variables that account for 80% of the variance in performance? Those are the ones that are the most critical to measure. Then what sort of time intervals are required for measurements or calculations? How much are you spending on M&V annually? I'm looking at a project. I looked at one this morning for a project in Philadelphia, and the M&V costs were estimated at about $600,000 a year. That's a lot of money for M&V. So, you want to be sure, you want to know what's underneath that in terms of what's required and, what are the specific activities that are occurring. And then, having a good description of measurement devices, how those devices are calibrated, are they up to stuff in terms of accuracy, are the equations well defined, assumptions, and all the data that's required to be collected to actually go into an M&V plan. Why is that important? Because shockingly, sometimes you'll find you have an M&V plan that's well defined and it requires you to have certain data, but then if that data is data that's got to come from an electronic control system of some kind, and sometimes that electronic data can disappear or go missing or be corrupted, or there can be a failure, and then you're missing data that you need for purposes of doing the M&V plan, in which case you'll have to come up with a second alternative approach of some kind. So in the plan outline, and this is typical and congruent with what NORESCO did for this, is that each ECM will have its own estimate based on measurements and calculations of what the savings are going to be. But then there'll also be the details of the pre and post activities. Here's what we did before the ECM was put in to establish baselines, and here are all the post-measurement actions we're going to take, and those will all be laid out in the M&V plan and in the other maybe contract schedules potentially. Especially a contract schedule for commissioning may be relevant, because sometimes you may need to commission the equipment before you do a post-measurement of some kind. So there can be a relationship between M&V and other components of the contract schedules. I already touched on this third bullet about who's out there actually witnessing measurements on behalf of the client or Board of Water Supply, and who's reviewing ESCO calculations and reports when they come back, those M&V reports. And that may be someone who's designated by the Board of Water Supply. But obviously, the better they understand what's being done by NORESCO and the technical details of the M&V process, the more effectively they can participate as a reviewer of calculations and reports. And lastly, if there are changes to equipment control strategies, how are they going to be implemented? And this is one of the areas where technically, I would say if there's an area that's probably the most significant for most ESCOs in terms of risk, performance risk, controls are a big place where performance risk can come in. But, risk also is opportunity. It's the same area where the big opportunities for optimizing and improving savings above the guarantee level also exist, because it's where there's technically a lot of variability. And so, yes, controls are really important because they can hurt you, but they can also help you a lot and help you exceed your performance. Very important to get the controls piece of any strategy right. And what is one of the things you might be looking at with an energy management control system or some other localized control device? You might be looking at trend log data of some kind, which you can use to evaluate what's happening with your equipment performance, how it's responding, how it's operating, and hopefully improve your project performance over time. You want to know in your M&V outline if there are changes to scope, which some have already occurred on this project, then how does that affect and impact the project savings? Well, you may have to go back and make a little change to the guarantee or make an adjustment and say, okay, because of this change to project scope, we've now increased or decreased the savings guarantee a little bit because there's a change, and that's not uncommon. In this case, it's actually occurred before construction begins. In the case of the DOT project at airports, there are a number of things they discovered during construction, I think, that surprised them a little bit, and they had to make some adjustments to scope, especially their lighting scope had some non-trivial adjustments, and then they made other adjustments, some at increased savings and some decreased savings. Okay, so in a typical M&V plan, you're going to really be also looking in the longer term in the second bullet. How do we monitor over the contract term? It's not just after we get the first M&V report, we read it, we discuss it, we have a meeting with Noresco, but what's the long-term strategy? And who's going to keep copies of the M&V plan? Who over the life of the contract is going to monitor and review this stuff, for example? And if there are changes, who's going to have an electronic file to memorialize those changes? And you may, Aaron, you may have already provided them. Did you ever provide them like a sample periodic savings report, just to show them like a format of what it might look like?
No, I don't think we submitted any example or anything like that. No.
Yeah,
No.
I know Ernie's probably familiar, and maybe Dave Nagamini is familiar from previous projects they've worked on what a sample periodic savings report looks like, but other people may not have seen one to get a feel for like how the data is laid out and what the various tables are, etc.
Yeah, we have as part of the initial process, the invitation for proposal process, we did get a sample M&V report. In this case, it was from DAGS, Department of Education Services. So we had that. Although I don't remember the term periodic savings summary or anything. It might be in there. I just don't know offhand.
Yeah, it probably, I'm sure it was one of their annual reports, so that would be it. And sometimes reports are made on a more frequent basis, like a quarterly basis for certain ECMs on occasion. So that's what I was sort of referring to. But an annual report will give you a lot of information.
Okay.
So this next thing is sort of about M&V. Why am I talking about objective measurement standards? Well, they're important. It's important to have your standards really clearly defined and project performance standards clearly defined. Why? Because if they're unclear, then that can lead to a misunderstanding or a dispute about whether you're achieving your performance objectives or not. So clarity is good. Uncertainty or undefined terms are not good. And if you lay out these measurement standards clearly, which the typical engineering savings calculation contract will do, if they're well defined in the contract, then that'll work fine. And in the vast majority of cases, they're not an issue. But if for some reason somebody disagrees about some data at some point in time, then these standards should be fair, efficient, technically sound, economically cost-effective, transparent, and this last one is consistent with standard industry practice. And everyone says, well, I understand why it should be fair and efficient and cost-effective and technically sound and transparent, but why that last one, consistent with standard industry practices? Well, the reason is, if you ever have a dispute about measured savings and you go to an arbitrator or you go to an alternative dispute resolution of some kind or even a judge, they're going to say, if it's not sufficiently defined in your contract, if there's ambiguity in your contract, and they can't find the decision rule clearly defined in the contract, they're going to figure out what the standard industry practice is, and they're going to use that as their standard to determine who's right and who's wrong. So that's why that one's in there. So what are some of the performance measurement standards? Well, we talked about this a lot already, but the first bullet, cost-effective measurement produces data. And it's got to be data with a value greater than the cost of measurement. Consistency is the second bullet. Somebody using this methodology, it shouldn't be so ambiguous that 5 different people use it, they get 5 different results. Then you've got an underdefined procedure. This one is, the third one may seem sort of obvious, but I'll tell you, it's not so obvious. Measurement must produce timely results. Why is that? We had some fairly lengthy delays at DOT at getting the M&V reports produced. Some of that was related to issues getting data, other factors. but it took a long time to get answers during the review process to a lot of questions that I had about some of those reports, and therefore it took quite a while to achieve the review. So depending upon what's at stake in terms of the savings that are sort of uncertain until you've figured out what's going on, not having timely results can be deleterious to your achieving your savings performance goals. And then must be reasonably accurate. I mean, that's sort of an obvious one. Not perfection, but plus or minus 5%, very good. I mean, you know, that's typically a good engineering standard to meet in terms of savings guarantee. If you're guaranteeing 95 out of 100, plus or minus 5%, you're going to be fine. And then lastly, having a defined resolution method for disputes if they should arise about measurement and verification in the contract. This next one is really sort of important, and that's now you've determined the units of avoided utility consumption, but how do you value those units? Well, you want to use accurate utility costs. And that can vary depending on the account or the meter and the particular rate schedule that you're on. Also, it might matter about if you are claiming materials and maintenance savings, they should be clearly documented and everyone should know how they're derived, how you figured out the baseline, and how you figured out the reduction or changes from the baseline that avoided future material or maintenance costs. And the best thing is to actually have these spelled out in the contract and determine, you know, and that would be the norm in most every ESCO contract. It would actually spell out so you could make sure when you went back and valued savings that you were applying the right rates to the right types of utility consumption for the right sites. So this is just an example. It's not meant to be accurate in terms of the specific numbers per kWh or per kW. It's merely to illustrate the point that between small facilities, you might have very high kWh charges, but maybe no demand charge. For a medium facility, you might have a lower kWh charge, and have a significant demand charge. But the really large facilities have really big kilowatt-hour charges, and I see there's a little typo stuck in there, but the highest demand charges. And so managing demand there can be very valuable. There might be nice opportunities there. So what are some of the sources of data for savings calculations? Well, trend analysis data may come from a building EMS or a dedicated local control system. There may be short-term metering or measurements, and that's particularly true when you're using option A, which is the primary method being used by NORESCO for this project. You may look at utility meter billing analysis, and that may be done simply as a cross-check on option A, you know, for curiosity. But then when you do that, you have to figure out all the other factors that are affecting utility meter billing, and that can be that is an exercise we went through at DOT and to some extent at DAGS on that project. And it's fine to do, but it does take some time and money and effort to do it if you want to. And then there may be computer simulations using eQuest modeling for some particular savings from a specific ECM. So the heart and soul of M&B to some extent is the baseline. And the baseline is that mutually agreed upon pre-retrofit annual utility consumption and cost for either the building or a specific energy using system in it. And in the case of BWS, I think in the vast majority of cases, this is going to be specific energy using systems or equipment. And this is really, it's important to get this right. Why is it important? Because it's the foundation, technically and economically, for the analysis of savings. If you get the baseline defined correctly, then it's good, and you'll be able to go back to it and use it as a standard of comparison. If you make a mistake in the baseline, then that mistake may propagate into your evaluation of future performance over time, and that can really be a problem. You know, so very important to get the baseline properly defined. Oh, go ahead. Somebody wanted to. I'm sorry, was someone wanting to make a comment? Okay. In the whole building in baseline types, the whole building utility meter data is one approach. Then there's the sub-meter data, like typically a dedicated system of some kind. A good example might be a PV system, which generates new output, and you could have a sub-meter on there to measure the kWh output. Then you may have specific systems where you're doing spot measurement of some kind, and you're doing short-term measurements, and then using calculations to estimate savings. Or you could use calibrated simulation data, like in an eQuest model. Or you could be using trend log data of an equipment operating profile to show what happens over time and how it changes over time and what its typical load profile is, and then see how it changes after you put in your new equipment or change your operating strategy. One thing that's sort of important here is baselines should be, you should link the baselines to the specific equipment or consumption that you're trying to affect, not the other utility meters for which the agency may pay utility costs but aren't part of this project. You say, well, that's obvious, right? Except, when we looked at this on the airports project, at one point, there were maybe 80 plus meters or so that were affected by the project, but there were another, 20, 30 meters that weren't part of the project. But when somebody started to look at analyzing utility bills, they included those other 20 or 30 meters. Well, makes your comparison not really that accurate because you're looking at a bunch of meters that are not really affected by the project. So, sort of basic, but important to look at. So, when you characterize a baseline, sometimes people think, well, I'm just looking at utility meter, or I'm looking at a short-term measurement of kW or something else. But I don't really need to be concerned about that, anything other than those short-term measurements of a circuit or the actual measurements from utility data, but actually you do, because a baseline for utility consumption does not exist in a vacuum. There's also the existing conditions, like what are the operating hours of that equipment? Well, this is obvious for a pump or for lighting, pretty important to know. What's the equipment load profile? If it's got variation in it, you need to know that. If it's lighting, what about the light levels that are delivered by the system? I could save you a lot of energy. We just will put in a light level that's half of what you have now. That may or may not be appropriate depending on what IESNA standards are. What are the temperature set points? I can save you money by adjusting your temperature set points, but it's also got to be appropriate to human productivity. I don't necessarily want a 78-degree indoor temperature, and that's my cooling set point, because nobody's going to want to feel like working very much. It'd be too hot. By the same token, knowing what your existing equipment operating efficiency is. Once again, that's something that's typically going to be determined by measurement. Even the level of O&M service is important. If there was a baseline level of O&M that's occurring and you're trying to impact that and change that going forward, and that's going to have some effect on how the equipment performs, you need to be able to verify, well, this is what it was in a baseline, and this is what it is going forward. I'm now verifying it, and this is why it has this expected outcome on the conditions that were present at the baseline. It may seem like I'm spending a lot of time on this, but I'll tell you, if you ever try to go back and cross-check utility bill comparison and you don't have this type of data, you won't be able to do it. Let me give you an example. On Maui, occupancy levels between 2011 and 2015 for passenger traffic through the airport went up by 20% over a 4-year period. Well, that affected cooling loads. So it's something you have to take into account. If you don't know that, it's not easy to take into account unless you have that data. So when you're actually defining a baseline, there's all those variables I talked about, but then there's how those variables change over time. Do they change slowly? In other words, you have fairly stable baseline conditions, or is there sometimes rapid variation, or are there significant annual changes? sometimes there's a phenomena called load creep or plug load in buildings particularly, where people keep adding more and more electronic equipment and more load, and the load is gradually creeping up, not because the ESCO project didn't do what it was supposed to do. Maybe it did, but when you try to look at the utility bill, you're not accounting for load creep of plug loads that are coming in and sort of being added to the system. And unless you're tracking that through scrupulously sort of monitoring it in terms of the internal complement of plug equipment, you might not realize what's happening. And the other thing is, what really is driving your variable loads? What are the key factors? Remember, we talked about the 20% of variables that account for 80% of the variation. That's really what you want to know. What are the crucial ones when you're defining your baselines? And then this last one, the last bullet, is sort of important, is how much time and data is required to adequately define a baseline. Is it a few weeks? Is it a few months? And it varies. It depends on what the ECM is and what the variability of that ECM is as to what's an appropriate set of data in order to define a baseline. So, some more data that may come in when you're thinking about existing conditions and baseline definition is, do you have a history of the operating logs on the equipment that you have now? Do you know what it's done historically? Do you have runtime data on it for, that you've collected from sensors? Do you have previous reports on testing and balancing for that equipment? Air flows, water flows? Do you have good maintenance records that are complete and go back a little ways during the baseline period? Let's suppose you define a baseline period as a specific year. Well, do your maintenance records and costs cover that whole year? Do they cover it comprehensively, or is there data missing that the accounting department doesn't have? That's important to know. So what are some of the challenges to calculating an accurate base year or an accurate baseline? What about if equipment is out of service? And this can happen. Equipment, suppose your construction were to go on for a couple years, which is quite likely it could. Suppose during the baseline period a piece of equipment was operating, then you go into construction and some piece of equipment that is going to be part of the project but is not yet scheduled for construction actually goes down. Well, this happened at DOT, and during the time that equipment was down, it wasn't drawing energy. Fortunately, they were able to isolate that out of the baseline period. But if equipment is broken or out of service, it's obviously not consuming energy. Well, then you need to know how long was it down for, and what was the impact on utility consumption. Another thing is that people sometimes are of the opinion that any data they get from the utility company must be completely accurate. Unfortunately, that's not true. Sometimes utility data is inaccurate or missing. I've found there can be a data entry error on the utility side, a billing error, could be even a problem with utility metering on occasion. I found all of those types of errors, and consequential errors on occasion that were worth tens of thousands of dollars of revenue on an annual basis. So, it's important to know when you're looking at consumption data. Don't just assume, I guarantee you it's accurate. Sometimes you may have to what's called clean or cross-check the data to be sure that it's good quality. Some equipment, runtime hours, can be very difficult to accurately measure. Normally I wouldn't say that's a huge problem, but once in a while it can be a challenge. So remember I said the heart of measurement and verification is reducing uncertainty. And so when you're trying to define the level of uncertainty and reduce the level of uncertainty by properly defining your baseline and existing conditions, they have found through research that a lot of the source of uncertainty of future performance really comes from a bad baseline definition. So when you're defining the baseline, you want a good data sample on the current equipment that's adequate in terms of the quantity of equipment sampled or measured, proper condition assessment of the equipment, good measurement of the operating efficiency of the equipment, and a good picture of the operating hours of that equipment. The more accurate you are on that stuff, then the less uncertainty there's going to be in analyzing future savings. So, what are some of the sources of calculation uncertainty? Let's assume for the moment that you got fairly good data that you collected from measurement processes. Well, if you're doing modeling with eQuest, there are user-specified inputs, and then there's default inputs that go into the model. And if a user puts in an input that's incorrect, or let's say not a good assumption, that can throw it off a little bit. Sometimes when people are doing spreadsheet analysis of calculations, it ought to be really straightforward. Spreadsheets are fairly simple, but the problem is if an error creeps in, if someone makes a bad data entry somewhere in a spreadsheet, then it may propagate throughout that spreadsheet. And I've certainly seen that happen many times. Also, there can be an issue with your M&B equipment data. If your equipment data is not properly, if your measurement equipment isn't properly calibrated, you could have a measurement error that gets, creeps in there. Once again, all these risks are manageable. It's just the more that you're aware of them, the better you can manage the uncertainty associated with them and reduce it. Some other challenges, I'm going to note a couple of them here. If you don't have the detailed supporting engineering calculations, like if your equations are underspecified, then you may get a sense for how they're going to calculate it, but you don't know exactly how they're going to calculate. If there's missing data on equipment condition or how it's been operated, we touched on that a little bit earlier. I'm paying particular attention to this third bullet, which is the lack of standardized data and formats for calculation and reporting. I actually wrote a whole memorandum on this for DBET and DOT and made a number of recommendations on how to format the data for M&B reporting, just because I found the way that it was being organized for the DOT projects made it really hard to review. And by getting a lot of data into tabular form and organizing so you didn't have to flip back and forth between 4 or 5 different pages to be able to figure out the appropriate comparisons, made it a lot easier to review when they adapted that format in their construction year 2 reporting. Just that fourth one is sort of things are always changing in facilities, and just having enough data to monitor the impacts of what it is that's changing, when it's changing, and what the impact of that change might be on ECM performance. I give Alan credit for this last bullet because he pointed out, one of the constraints on the DOT projects was not having enough staff for the scale and scope of projects they were implementing internally to analyze and verify all the savings calculations, which is why they ended up, contracting with me. But it's also important to have good training for your operators, and because when you have operator turnover, there can be a gap in the staff knowledge of what's going on with your equipment, and that can affect your future equipment performance as well. So here's a more generic look at types of performance risk, and this is just sort of expanding the question of risk up to the 10,000 foot level. Well, there's the obvious thing. Your equipment performance can simply degrade over time, especially if operation and maintenance is not adequate. But even with adequate O&M, there will still be some inevitable degradation due to thermal effects, etc., things like that, mechanical effects on the equipment over time. You can actually have a failure of mechanical or electrical equipment. It may be short or long-term failures. There can be a failure of the controls, which once again can be short or long-term. You can have a significant change to the building use. The agency may make changes to the space or equipment that have an impact. And there could be a change in the available technology and the performance of the technology, and that may I wouldn't necessarily, performance risk, it's going to change your performance risk profile. It may improve it because now you may have a better technology that will reduce uncertainty, and maybe you can incorporate it into the project at a later date. So just once again, thinking about all the variables that can impact performance. Then after you start tracking these variables, you want to start thinking about, well, how are the savings going to be over time? And what allows you to maintain performance over time and for savings to persist? Well, one is, if you're always focused on improving performance or optimizing the system to make the schedule the best, to make the operating environment optimal, to fine-tune the controls, then all of this stuff helps you make savings persist over time. And that's supported by effective maintenance. It's also supported by monitoring savings, because the more you're paying attention, it gives you a sort of a data visibility window to look in and see what's going on with my equipment, and is it behaving as I had hoped it would behave. Good, it is, then I'm probably getting my savings. So what about using main meter, utility meter baselines? Well, these are just a few cautions on, a lot of times, especially I find finance people are in love with the idea that we'll just use the main utility meter baseline and it'll answer all our questions. But these are some things you need to be aware of when you use a main utility meter baseline. If you use multiple years consumption to obtain a representative 12-month average, that representative average year has to be used with care, because sometimes it can mask increased consumption like load creep that's occurred, like say over a 3-year period. And it doesn't seem to be that much of a change year to year, but actually if you look carefully at the month-by-month data, you'd see there was load creep going on. But when you smush together the 3 years into an average, it may disguise some things that are actually occurring. Also, there can be a non-recurring event stuck in there in one of your years that you pull into an average and it's out of whack and it improperly skews the baseline. So the thing to remember about utility meters, they're really designed by utility companies to get revenue for the utility. They're not really designed to manage your end-use loads. That wasn't the primary reason. Now they're talking about with smart meters that we'll get to the goal where, they'll be able to do some load management with your smart meters, but by and large, they're called revenue meters for a reason. They're there to get revenue. Okay, so why do
Dave?
Oh, go ahead. Yeah.
This is Dave Nakamine. One thing that comes to mind is, let's say you have a pretty large construction project that affects utility usage.
Sure.
Yeah, that can skew the baseline quite a bit, or the measure.
Absolutely, it can, and you need to sort of get as good information as possible as you can about what's going on with that project. Especially the time when it went on and what loads it might have imposed on the meter, to sort of normalize any comparisons to figure out what's happening to the extent you're using a revenue meter for comparisons.
Okay.
But yeah, that's a good point.
Dave, this is Mark Chan. Just more looking at terms of time, you're roughly about halfway through your slides.
Yep.
Maybe in the next couple of slides, if you could find a nice breaking point as far as categories, maybe we'll take a 5 or 10 minute break.
Yeah, you and I were thinking the same thing. I'm thinking I'm going to get through another 2 or 3 slides or 4, and then we'll maybe take a break at I guess it would be about the 10:30 mark for you, right?
Sounds good. Okay.
Yeah. Okay, that's my plan too.
Okay, thanks.
So, why do what NORESCO is doing for the Board of Water Supply project largely? Why measure individual end-use equipment? Well, there's a lot of advantages to it. It isolates the affected end-use consumption from a total building meter. That's one thing, which if there are a lot of other loads on that meter, can be problematic, sorting out the signal from the noise. Also, it quantifies parameters for engineering calculations and simulation models, like a runtime or a fan speed or a control setting, etc. It can give you good data on what's going on with the equipment itself, if you're taking spot measurements. And sometimes, especially with lighting, people like to rely on catalog data for estimates of consumption. But catalog data estimates of consumption are done under more or less ideal conditions, and they may not accurately simulate the field conditions, because even lighting performance is affected by thermal conditions, etc., to a degree. So spot measurements and individual end-use equipment measurements may give you a more accurate picture. The other thing that's nice is it focuses on the specific equipment system performance. If you know that's where a lot of your consumption is for a particular load, like a big pump, you know that that's where a big opportunity to avoid future consumption lies. And if you can focus your performance optimization on that piece of equipment, individual end-use measurements can help you do that. So what are some more potential data errors? Well, we already touched on this one. If you use an inaccurate measurement device, or it hasn't been recently calibrated, you could have an issue. Then whatever units you're measuring, make sure you're measuring the right units. Of course, with water, this matters because it could be in hundreds of cubic feet, it could be in K gallons. You want to know you're using the right units. And even things like power, using derived power, using volt amps in lieu of kW. Or, what about you took some measurements, but then you missed some measurements, or you couldn't get in to get a measurement of something you needed to, and you're going to have to come back and measure it later, and it shows up as a 0 or null value at the date of the measurement date when you did it. So all potential things to watch for. Then if you're actually looking at metering, or to the extent you're looking at metered data that does come from a utility meter, whether that's a revenue meter we were talking about, sort of like an option C whole building approach, or even if you have a dedicated meter for a particular system that's continuous, you want to make sure it's collecting valid data, and you want to focus on, is it reasonable to have someone to analyze all that data? The moment you start talking about, I've got 100 meters and I have to look at the data from all of them, that's a lot of data to look at and analyze. And then you have to be sure all the information is converted to economic data carefully, and that it's focused on the right components of the utility bill. Because there could be fixed charges in the utility bill. Well, no matter what you do, you're probably not going to avoid that fixed charge. So it's not a variable cost, and you want to be looking at what are the variable costs that I can actually impact on my utility bill. And then you want to balance the cost of metering with savings and risk. If I'm going to put a dedicated meter in, I want to be sure that that meter's giving me cost-effective data and it's actually helping me reduce the risk of performance uncertainty. So I'm going to just touch on a few routine baseline adjustments. If you want to evaluate savings, to adjust the baseline use for current conditions, that's a pretty common thing that can occur. And these are just some examples. Fan speed, a scope change, additional equipment loads, changes in control set points and schedules. All of those could require you to make a modest adjustment to a baseline. And that could impact the savings guarantee in a small way, typically. Now, there'll probably be some types of adjustments that fall into what we would typically call a deadband area. In other words, the ESCO will probably tell you, if they're training your building operating maintenance staff, look, if you do a short-term adjustment of the operating hours for this amount of time on this load, it's not going to affect savings that much. And it sort of falls in a deadband category where that's an expected level of variation. But if you do it more than that, and it stays that way for a long period of time, then that will affect and require a baseline adjustment. Some non-routine adjustments, and these happen more, unfortunately, a little more commonly than you might think. What about replacement of utility meters? This is something you guys might be familiar with, but have you ever heard of this idea that old water meters can run sort of slow? And when you put in a new water meter, it can actually start showing the correct consumption, whereas before it was showing you consumption that was a little low because it was running slow. So if someone's paying a water bill, that can matter to them, because I've seen cases where a client was being undercharged because they didn't have accurate meters by tens of thousands of dollars a year, and when the utility company put in accurate water meters, suddenly they were getting the real bill that was more up to date and they had to pay a lot more in their water bills. But believe it or not, I've also found, although less frequently, I found problems with electric utility meters and gas utility meters both, and had to actually make adjustments to project performance due to problems with utility meters. Fortunately, it's not super common, but it does happen. Then you can have service outages or power quality impacts on equipment. You can have a project delay. You know, you might have a schedule that says your project's going to be completed by such and such a date, and the savings are going to start flowing from that PV system you put in. But if the utility delays your interconnection agreement, well, maybe you have everything you need to produce power and the system's operational from your point of view, but if the utility doesn't let you interconnect, you're not going to be producing necessarily any useful power to operate it until you get that interconnect agreement perfected and approved and so forth. So that's just some more non-routine types of adjustment. Or you can have an yeah, go ahead.
Okay. So how important is calibration of these measuring equipment?
Well, I'd say it's sort of a routine thing. Most ESCOs, anytime they're using field equipment, they will show you like a calibration certificate for it as part of their M&B plan to show that, you know, this is what we used to measure, you know, power or runtime or whatever it was, and this is the instrument we used, and this is how we calibrated it before we took these measurements, or, you know, or this is its most recent calibration time. I mean, you don't have to calibrate them every week, but they'll show you a current calibration certificate. I mean, I don't know, Aaron, you want to make a comment about that? What your typical practice is?
That's typically what we do. You know, for example, on simple measurements for lighting, you use a fluke meter. We have those calibrated every so often based on normal intervals, kind of like what you're saying, and we provide all those certificates exactly like what you're saying.
All right, I think this might be a good time for a break at slide 47. You tell me, Mark, what do you want, like a 10 or 15-minute break?
Okay, let me